Welcome to another interesting session on vector algebra. We shall look at vector equations of lines. Vector equations on lines. There are two ways we can find the vector equation of a line. The first is to find the vector equation of a line that passes through a point, let's say A, and parallel to a given vector. Then, in another scenario, we can also find the vector equation of a line that passes through 2 points. We shall illustrate this using the two-dimensional graph, the 2D space. On our screen is the x and y axis. We are interested in the yellow line, and that is what we are going to find the equation in vector form. This yellow line passes through this point A. And the same yellow line is parallel to the white vector here. Let's call that vector vector B, the free vector here, vector B. This is the origin. Hence, OA is a position vector. So I can label here A. And this portion, let's call it R. A, R, and a portion of our yellow line forms a triangle. Let's refer to that little portion C. Said that we have three vectors forming this triangle. The vectors are A and C. And our yellow line is the line we are interested in finding its vector equation. The vector equation that we have to provide will be in such a way that it will be an expression for R, said that anywhere we move these vectors along this line, the relation we will give to R will still be true regardless. We also know that since vectors R, A, and C are the sides of the triangle, then the triangular law of vectors can be used. By the triangular law, R is the resultant of A and C. And as such, we can say R, the vector R, is equal to A plus C. In most instances, the vector C will not be known. But the vector C, which is just a portion of the yellow line, lies on the yellow line. And since the yellow line, or the white line, is parallel to the vector B, we can hence conclude that vector C is also parallel to B. You can recall from previous lessons on power vectors that two vectors are said to be parallel when one is a scalar multiplier of the other. Hence, we can write C as equal to some scalar multiplying B. Let's call this scalar lambda. So we can say C is equal to lambda B. We shall therefore replace the expression lambda B with C. So we will rather replace C with lambda B. So our R will be equal to A plus lambda B, where lambda is a scalar. This relation therefore becomes the vector equation for the given line. This illustration is on a 2D space. However, this equation is also applicable for a 3D space, a three-dimensional space. So the vector equation of a given line which passes through a known point A and parallel to a given vector B is given by R equal the position vector of A plus lambda multiplying the parallel vector B. This time we are going to look at how to find the vector equation of a line that passes through two given points. A vector equation of a line that passes through two given points. Let's call these points A and B. So this line passes through point A and B. In that scenario, since this is the origin, OB become a position vector. Let's call it B. And OA is also a position vector. Let's call it A. And then call this arbitrary vector which passes through some point here. Let's call it P, R. Good. Now, with the same scenario, AP, let's represent vector AP, the movement between A to P, as C. In the same scenario, we can write a resultant vector equation for this triangle OAP. R is the resultant vector to A plus C. As said in the previous video, most of the time the vector C will not be known, but since the vector C has the same direction as the vector AB, if there should be a vector on AB, if there is a vector on AB, C is parallel, same direction as what? AB. So C will be equal to some constant. Let's call that constant lambda multiplying vector AB. And we know vector AB can be computed by using the position points A and B, and that is b minus a. If you could recall from how to find the position vector of a vector passing through, how to find a vector passing through 2 points. So this would be lambda multiplying b minus a. So we can replace this expression with c, and then we are going to have a plus lambda multiplying b minus a, and this becomes the vector equation for a line which passes through two given points a and b. Let's look at some examples. The first example: find the vector equation of the line passing through the point 7, 3, 4 and parallel to the vector 4i plus 2j minus 2k. So this question is the type 1, where r is equal to a plus lambda b, where b is the given vector which the line is parallel to, and a is the point the line passes through. So this shall be our point a, and this vector is our vector b. Therefore, our vector equation can be written as the position vector a, which is 7i minus 3j plus 4k, then plus lambda multiplying 4i plus 2j minus 2k. So that is all. You can also decide to represent your answer in column form, and that will be r is equal to 7 minus 3, 4, then plus lambda 4, 2, then negative 2. The answer can also be left in this form. Let's look at another question. Write down the vector equation of the line which passes through the points with position vectors a and b. A is 2i plus 2j, and b is 9i plus 4j. We shall express the equation in column vector form. So this example is type 2, where r is equal to the first point plus lambda multiplying b minus a. So our first vector is 2i plus 2j. Then lambda multiplying b minus a. So let's subtract 9 minus 2 will give us 7i. Then 4 minus 2 will give us 2j. The question says we should express it in column form. So we have 2, 2 plus lambda multiplying 7, 2. Let's look at the last question, and then we'll now look at how to represent our answer. There are so many ways we can represent the equation of a line in vector form, so we'll look at some of them. We have to find the vector equation of the line which passes through the points -4, 8, negative 1, and then 2, 1, 0. And we have to use the parameter lambda. Good. So this is the type 2, where R is equal to the position vector A plus lambda multiplying B minus A. So let's find the expression B minus A somewhere here. The position vector B minus the position vector A. Obviously, the first point will be our A and the second point will be our B, in that order. So we are going to have 2, 1, 0 for our B, and then negative 4, 8, -1 for our A. When we perform this subtraction, we are going to have 6, then 9, and then 1. So our answer will be the position vector for the A vector, which is minus 4i plus 8j, then minus k, then plus lambda multiplying 6i plus 9j plus k. So let's look at the options that best answer this question. Okay, I think we have made an error in the subtraction of B minus A. So 1 minus 7 will give us negative 7, not 9. So let's do that correction. So sorry, 1 minus 8 will give us negative 7. So let's do that correction. So this is 8. 1 minus 8 is giving us negative 7. Negative 7. In that instant, we'll have minus 7j. So let's do that correction here. Minus 7j. Good. So the correct answer will be the C. Now, in this section, we are going to learn how to express the vector equation of a line in Cartesian form. The vector equation of a line in Cartesian form. We already know that if a line passes through the point A with coordinates A1, A2, A3, and is parallel to the vector B, also with coordinates B1, B2, B3, the vector equation is given by R is equal to A plus lambda B. Since R is also a vector, let's denote its coordinates with x, y, z. Then the coordinate of A, let's write it in the column form. A1, A1, A2, A3. then lambda multiplying the coordinate of b1, b2, b3. We can write these equations. X is equal to a1 plus lambda b1, and then y is equal to a2 plus lambda b2, and then z is equal to a3 plus lambda b3. Now let's make lambda the subject in all these equations. Making lambda the subjects in the first one, we'll have lambda is equal to x minus a1 over b1. Then the second one will become lambda is equal to y minus a2 over b2. And the last expression, lambda will be equal to z minus a3 over a3. Sorry. Now, since all these expressions are equal to lambda, we can just quickly conclude that x minus a1 over b1 should be equal to y minus a2 over b2, and this in turn will also be equal to z minus a3 over b3. This becomes the Cartesian form of the vector equation of a given line. Let's look at some examples on this concept. We have to write down the Cartesian form of the equation of the line which passes through the points A, 2i plus 12j plus 3k, and B is equal to 2i plus 7j plus 7k. First, we'll determine the equation of the line in column form. You can recall that this is type 2. The equation of a line in vector form, the vector equation of a line that passes through 2 points. This can be obtained by using the relation R is equal to A plus lambda B minus A. The coordinate of A are 8, 12, and 3. That's the component of A. Then plus lambda multiplying b minus a. So let's compute b minus a. We are going to have 2 minus 8, which is negative 6. Then 7 minus 12, which is negative 5. And then 7 minus 4, which is positive 4. If the coordinate of R are x, y, and z, then the following equations can be written. X is equal to 8 minus 6 lambda. Then making lambda the subject, we are going to have x minus 8 over negative 6 is equal to lambda. Then, with the y component, we can say y is equal to 12 minus 5 lambda. Making lambda the subject, y minus 12 over negative 5 is equal to lambda. Then the last one, z is equal to 3 plus 4 lambda. This will be z minus 3 over 4 is equal to lambda. So since all these expressions are equal to lambda, we can equate them together to form the Cartesian form of our vector equation. So let's look at the alternatives and see which one has these three forms. So the first one should be x minus 8 on negative 6. So you can see the c has it. So this one is out, this one is out, and this one is also out. But let's compare the others. The next is y minus 12 over negative 5, it has that, and then z minus 3 over 4. So we'll go for this option as our answer. We have to use the information above to answer question 6 and 7. And we are given the vector A and B. We have to use the vector A and B to compute the equation of the line that passes through vector A and B. So this is type 2, where R is equal to A plus lambda B minus A, sorry. So obviously our A, which is 2i plus 2j plus 3k, then plus lambda b minus a. Let's perform the subtraction. That will be 9 minus 2, which is 7i, then plus 4 minus 4 will give us 4j, and then 8 minus 3, that will yield 5, so 5k. We shall compare that to the alternatives. We know definitely the first one is out and the last one is also out. So let's look at this. The B, option B, 2i plus 2j plus 3k. For the first part, it has it, but because of the negative 7i here, we will not pick the B. So the correct answer here is C. The correct answer here is C. Good. Let's look at this, the question 7. We have to express the equation in question 6 in column form, column vector form. So it is just our answer that we are just writing it in column form. So the first column vector will be 2, 2, 3. So let's look at the one that has 2, 2, 3. 2, 2, 3, 2, 2, 3. So this one is out. This one is also out. So obviously the answer will be between A and B. Let's look at the other part. We should expect 7, 4K. 7, 4K. Is this 7, 2K or 7, 4K? Let's check our 2 over here. They had let's perform the subtraction again. 4 minus 2J. Okay, so here is 2J. Let's do the correction. Here it's supposed to be 2J because it's coming from the J component here minus the J component here. That's your 2J. So here is 2J. Good. 2J. So let's see whether even I picked the correct answer. Yeah, 7I plus 2J plus. Okay, so that is that. So we are expecting 725 in this scenario. So this is the correct answer. This one is also wrong. P is a point on the line segment joining the points 3, 2, -1 and 6, -4, -2. If the x coordinate of P is 5, to find the y coordinate. So this one is the application of the Cartesian coordinate. Good. So first we will find the vector equation of the line that passes through these 2 points, and the vector equation of the line that passes through 2 points is given by A plus lambda B minus A. So let's make the first point A and the second point B. So in that scenario we'll have 3, 2, -1 plus lambda multiplying B minus A. Let's perform the subtraction. 6 minus 3 is 3. The -4 minus 2 is -6. Then -2 minus 1 is -3. -2 minus 1 minus 1. So -2 minus -1. So that will give us -1. Good. Obviously R will have the component x, y, z. Okay, we know x will be equal to 3 plus lambda multiplying 3, or otherwise 3 lambda. We know the expression for 3, for x, sorry, say the x is 5. So 5, since P is on the line, it should satisfy the equation of the line. So that's why we are using its x coordinate to be 5. P is on the line, so this equation, vector equation of the line, P must satisfy it. So if at the point where P, the x coordinate of P is 5, we can come and put it into this equation. So the x at the point P, let me even write that. At the point P, x is equal to 5. So it implies 5 is equal to 3 plus lambda, sorry, 3 lambda. Solving further, we have 2 is equal to 3 lambda. And our lambda will be equal to 3 over 2. Since we are supposed to find the y coordinate, we'll pick the y line y is equal to 2 minus 6 lambda. So y will be equal to, now we know the expression for lambda, so minus 6. Sorry, this lambda should have been 3 over 2. Let's do the correction. Sorry, 2 over 3. 2 on 3. Good. So we are going to have 2 on 3 here for lambda. So when we simplify further, we are going to get 2 take away 4. And the final answer in this case will be what? -2. So we'll select -2 as our answer.